but I have never seen an IBM going to a CIO with a shotgun and saying, you can't leave the mainframe, you have to stay here. So I vegan sausages, but I like meat sausage. I buy vegan sausages. And it's not about the sausage, it's about the fork and the knife. Not music is actually not that much different than coding. If it sounds nice, it's maybe the same thing as if they produce a good program. So
who understands Bach music probably would be a very good in
yes.
Programming, I would say. Good afternoon, everyone. Welcome to the very first edition of Mighty Mainframe interview. Today, I have Tobias Leicher with me. He's a very cool guy and he knows pretty much about all the things mainframe. So I think he's the perfect guest to start this series of interview. Welcome, Toby, and thanks for coming.
Thanks for inviting me. Thank you very much. Happy to be here.
People are talking about the mainframes and future of mainframes, and obviously there are some challenges and there are many good things around the mainframe. So what you think, what is the future ahead of mainframe and how we are going to future-proof the mainframe?
So I think when you look at it, I think people probably the last 20 years or the last 30 years got told that it's the end of the mainframe and that we move everything somewhere else and everything will be good. And I find it always very interesting because it feels that these people say, yeah, something is holding us back, and they always think like it's IBM maybe forcing them to stay on Z. But I have never seen an IBM going to a CIO with a shotgun and saying, you can't leave the mainframe, you have to stay here. So I think there might be, after all this time, some reasons that are technical why the people are still using mainframes. And I think we're in IT, so you can do everything with everything. Of course, that's the good thing in IT. You can, in real architecture. So I'm an architect by profession, an IT architect. So when I think about comparing my work with proper architects, like you couldn't put on top of Eiffel Tower 50,000 people living block. You wouldn't do that. But in IT, you can. We have just enough CPU resources. You can do everything. So sometimes we build very strange architectures. And it seems that the mainframe is very good at some very, very, very important use cases, like being very transactional, working with a lot of input and output data. So that's pretty cool. And I think that's the reason why we are still around, and we are very good with these things, especially when we want to secure them a lot. So there is a good reason why we are still there. But of course, we have challenges. And one is, of course, getting new people to the platform, because for such a long time, everyone said it will go away. So young people will say, do I really want to do that? Or do I want to do something else? And I think one of the more technical issues with that is that sometimes the mainframe is still used as it was used 30, 40 years ago. And that's not really necessary anymore. If I'm a developer, the only thing I do is develop code. I don't really have to do a lot with the mainframe itself. So it is actually possible to fix that. And all the things that we can fix, the challenges will remain. How can we make it attractive? And how can we actually find the right spot for it in our IT strategies? And I think that is important, to have some solutions for questions that people have, but also to accept the fact that we produce so much IT in the last decades that we can't quickly move it off somewhere else. It will, I mean, actually we will become less and less people in this world eventually. Maybe not at the moment, we're still growing, but eventually we will be less people.
See.
And when we are then less people, we will still have a lot of IT to manage. And so we need to make sure that we keep the things that we have and that are good in a good shape, so that we can actually carry on with it while we produce new stuff all the time. And so I think mainframe is still very well equipped for that. It's a modern technology. It's not like your father's mainframe where you have to go with punch cards. It's a modern 7-nanometer architecture. It has all the cool and hip stuff. It has an AIU, so an AI accelerator on chip. Pretty cool stuff. But we need to make people aware that it is there, and we need to use it when we already have something there.
Already for a number of years, people are talking about mainframe modernization. So this is a rather wide topic, and sometimes it was even a hype. So what it means for you? I mean, when you say mainframe modernization, many people say in-place modernization. What does it mean for you?
Yeah, for a long time, actually, when people said mainframe modernization, they didn't mean in-place modernization. They thought like modernize it means put it somewhere else, on x86, in the cloud, whatever you fancy these days. And I think that changed a lot because we realized maybe the cloud has a lot of advantages, but for the high transactional workload, it's actually not built very well. Microservice maybe not the ideal home for a core banking solution. And so in-place modernization means, to me, make the best out of what you have. So basically, a lot of the code that has been written is easily said like, oh, that's a monolith, it needs to go away. Basically, nothing is bad with a monolith. Even Amazon admitted earlier this year that monolith architectures can be a very good architecture. So why not? So what we need to do is we need, of course, to get rid of our technical debts, because we, over the year, especially when people said like, oh, it will go away, they stop to invest in it. They stop to modernize stuff, or they stop to keep stuff current. And I think we have now this depth in our back pocket that we need to get rid of. So we need to spend some time and actually modernize where it makes sense, use new technology where it makes sense, but also maybe have a look at my old code that I've written 10 years ago and think like, I could do better now. I know now better. I know the business terms much better. So keep stuff in a maintainable state, because the longer we wait, the harder it will get to actually make it more useful anymore.
That story around modernization, I mean, the technology advances was very, I mean, IBM was adding more and more good stuff on the mainframe already for more than a decade. But my personal feeling is somehow that the acceptance from the customer's side was somehow lagging behind. And recently, maybe in the last 2-3 years, I have a feeling that we are catching up. Am I right? What's your opinion on?
I think the biggest issue with changing anything actually is that you have three big enemies. One is we always did it like that. The other one is we never did it like that. And the third one is anyone can come and tell me to do it different. And I think that took quite some time to overcome it, because people on the platform, they had the feeling, we know it. We know what we do. Why would we use something else than COBOL? It's fine. Why would you do Java? That's so modern. That's so new. Why should we do it? And now, of course, after a while, we realized that these things become actually production. You can actually use Java for good things. You don't need to have everything written in COBOL. And young people arrived at the platform. The company started to hire young people again, and that drove a little bit of the passion to modernize things, to make things a little bit different. Because, I mean, these young folks, they didn't want to do just what everyone else was doing all along. They wanted to try out new things, and that helped us, as well as the understanding, and I think that is equally important, that the mainframe will not go away. It will need some time to actually modernize things, but it will not go away, because they tried for a long time and it didn't work out. So now they, I think, are more willing to accept the new technology that we have around to help them to modernize.
Yeah, I was in Montpellier 2 weeks ago, and there was a very nice story by a Dutch guy, Frank der Waal, about the differences developing mainframe stuff in Python and Rex. And he described pretty well this attitude that you just mentioned. Why the hell I need to change anything? I mean, my Rex script works perfectly well. Why the hell I need to switch to Python now? But I think that the answer is pretty obvious, especially for young guys.
Yeah, and also, I mean, it's like I still think Rex is a cool language, and no worries with that. But especially when I want to integrate, myself with other platforms, it becomes, of course, a question on what is the common denominator, what is the language that we all speak, and of course we can try to force everyone to learn Rex. Good luck with that. That's not going to happen. So we need to agree on something that is well used. And Python has been around for ages. Ansible is kind of seen as the new de facto standard for automation and automation tasks that include a lot of different platforms. And why don't just agree and do that? And I think the cool thing on Z is then integrate it with your Rex. Make sure that you can call the existing system automation stuff that you have, but use, where it makes sense, a lot of Python. And I think adding stuff to your toolbox never is hurtful. So that's a good thing.
If I remember correctly, back in your in the days, you were very much busy with all the things around the kicks.
Yeah.
Right. And what's your opinion? I mean, you already mentioned Java, and the reasons for moving to Java are more or less the same, like we described with Python. And more, I see that customers have COBOL and Java coexisting on the same platform. How do you see the interoperability and the performance issues that we had in the early days of Java? What's your perception of coexistence of COBOL and Java today?
I mean, in the good old times when we had HPJ, high performance Java, that basically was compiled Java, and at the time it was like horrible. Why could you do that? It's an interpreted language. Now, when we look at Quarkus and we look at more fancy JVMs these days that are compiled again, we think like, oh, we've seen that before. But anyways, so I think of course when we started Java on the Z platform, a lot of things were different. We didn't have the high frequency cores. We were on a Z890 or something. It was still like very, very, very low frequencies. We didn't have as much memory as today. But when we look at today, the performance of the machine is, I mean, it's terrific. We have like a 5.2 gigahertz core. We have lots of memory if you want to. And so the base values are all good for Java. And I think the other thing that changed is that people started to build Java at the time anyways. They just built it off platform and they tried to integrate it, and it's very hard to integrate it. So I think I saw a few customer projects where we basically took something they developed off platform and just ported it on Z, and the people were very reluctant and they were like, oh no, we don't want to go on Z. Then we need to develop an ISPF, our Java code. And I was like, what a crazy idea. You just develop it as you always do and then just deploy it to the Z machine. And so it took some time to convince people to do that. And I mean, especially in Kix, it's very good because the integration of the language with the other environments is pretty straightforward because it's using the same technology that the Kix guys always had. They always were able to link different programming languages with each other with Exakix Link. And that was, of course, a big benefit of Java and Kix because the integration felt very, very natural. And I think that is a lot of people actually worked with Kix found, that is what they found, that they thought like, okay, it's not that complicated. It's actually not that different. Let's just have a try. And then we figure, of course, performance is still a question. So when you switch between programming languages, there is a cost for it. And it is maybe an acceptable cost when you like switch for a longer time. But when you switch forth, back, forth, back, forth, back, forth all the time, now, of course, it becomes at least a point you need to consider. But we found actually that also another thing that a lot of people thought about Java, that Java will always be more resource hungry than COBOL is, that's actually not true. I mean, with memory, I would always say Java will definitely need more memory. But CPU-wise, if you have a good jittered Java program, it's actually in the same ballpark of any COBOL application. But of course, saying this means to have a good COBOL application and a good Java application. If you have a shitty Java application, it will perform shitty. But same is true for COBOL. We just are not used to that anymore because for 40 years, we optimized it as hell. And now every COBOL application, it works charming. But we could also write bad COBOL, and I've seen a lot of that.
You mentioned deploy. What's your thoughts around the DevOps? I saw recently also many customers are moving to this modern DevOps tools and scripting and automating. Somehow I feel it's the same dilemma that we discussed earlier about mainframe people being reluctant to move from something which works pretty well, and the other half of the universe who are doing something else. So recently we've done interesting project for the big bank, and they were pretty happy about DevOps. And in the end, I think the whole point around DevOps is to have a single DevOps procedures and tools around the whole enterprise. So is it the right time to integrate the DevOps on mainframe with the other platforms?
Yeah, I think the thing is, of course, the development process we have on Z works. I mean, it worked for quite some time, but it has some very specifics, like, for example, that it's usually a very monolithic approach. So we have the source code control, we have the build engine, we have all these things in one basic solution. And as we look at why the things actually develop more into this pipeline approach, we find that different parts of our development process tend to use different tools today. We don't have these big tools anymore. We use smaller tools. We use open source software for one bit. proper compile or proprietary compilers for others. So this changes a little bit, and I think that idea is generally a good one. And we on the mainframe, we sometimes tend to think that our mainframe is defined by how the tools work we interact with. But I had actually a call with an IT leader this week, and he said like, oh yeah, you talk always about this modern DevOps mainframe thing, and to me it feels a bit like vegan sausages, but I like meat sausage. I buy vegan sausages. And it's not about the sausage, it's about the fork and the knife. And we sometimes on Z, using development on Z feels a little bit like eating, not with fork and knife, but with chopsticks. And chopsticks are complicated to do. If you're not used to it, then you find it hard to do it, at least when you're born in Europe. So the only thing that I say is let's use the same fork and knife as we use for every other platform. There's nothing special
I like it.
how you do the code. It is more about, do I get the code done? Do I get my code into the machine? And it's not important how I do it. And if the young people don't want to live with ISPF, that's totally fine for me. We will not take it away. Use your preferred editor. And I think everyone can agree that it's a good thing to have code completion, because that is maybe one of the reasons why old COBOL programs had this very good variable names like COB1, COB2, COB3, COB4, because you don't want to type that much. That's annoying. So of course you have very short variables, but that's very hard to read. Nowadays you can have long variables. In COBOL, the compiler eats it for ages, so you can have long variables, but it's annoying to type it. So if you have code completion, you just don't need to type it anymore. So that's a pretty cool thing. And so I think there's a lot of value in using modern IDEs, but also in using modern development pipelines. You can do a lot more of something we traditionally didn't do on Z. We traditionally didn't do automatic testing a lot because we didn't have the tools, because it was expensive, we had not enough CPU for it, but now we have, and we really need to do that, because if we want to change something, we want to make sure that we didn't break something else. And that's why we need automated tools, automated testing tools, and we need to do more things. And that is in a modern DevOps pipeline far more easy to do than it would have been even possible in other traditional library managers. So I think it's a good time to switch, and I think it's also a good time to think about it. But of course it's challenging. I mean, 40 years of development process, or 30 or 20 years, are built in these tools. So we need to think on what we really want to do and how to do it, and how to do it step by step.
Would you say that it's good recommendation for all customers to go into that direction, or there are some special cases which should better stay on the existing tool
I think
set?
if you decide to stay, and you have the people that understand it, and you have the right people working on it, and you make a conscious choice, for whatever reason, I can't judge. I mean, that depends, of course, on everyone to do that. But if you have that, that's totally fine. We will not take anything away. We will not make you.
I see too many ifs in your.
Yeah, and then, but in the end, I would say, why? What is the single important thing that makes your development process so special that it needs to be different than anyone else in the company? I see the big advantage in having the same process for developers, because then also today we're talking about we can't find COBOL developers. And I'm always like, is it really the COBOL thing? I'm not sure. Everyone can learn COBOL in a weekend. It's very simple language from the syntax. But the complicated thing is how you develop. And just imagine when you have a developer that's actually responsible for a big Java application, but once in a while he needs to make a change in one single COBOL program. If it is the same environment and he just checks out from his Git this one COBOL source, he reads it and he quickly will understand what it means. He's able to change it. If he has to switch in a very different environment, need to have RUCF allowance to open ISPF panels, blah, 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 he will feel like, don't touch it. Let me correct it in my Java code, and I will not able to change it. So I will do the translation of the modern language in my modern languages, so that I don't have to do it on there. And that's like horrible. We don't want that.
Yeah,
so I would say go for it. It's painful maybe sometimes, but it's worth the pleasure at the end.
To us in CROZ, Munich and Germany is our second home since we opened a new company almost 2 years ago. So we've been more and more active in whole DACH region. I mean, Switzerland, Austria, and Germany. So being your home territory, what do you think? What are the specifics of DACH region in terms of mainframe? I'm thinking about the technologies and tools, and especially gap skills. I mean, how do the customers are handling those things in DACH?
So I think when you ask for general like state of mind things, I think what people in DACH, I would even say all of Europe, but especially in DACH, they are very proud of this German engineering, and they try to build everything themselves, to say it nicely. Sometimes when I'm annoyed by that, I say this is this DIY culture. Everyone needs to do everything themselves, and it's maybe very clever, but you need to maintain it for ages. Whereas when I look to the other side of the pond and you look to America, people would never do that. They always buy ready-made solutions and they just use it. And if something breaks, they just complain to the vendor. And that's very different here in Germany. People would ask for functionality, and if the company like IBM didn't provide it, they just wrote their own tool for it. And that, of course, generated a bunch of legacy tools that they still carry around. And sometimes you don't even know, do you really still need them? Maybe it's already part of the base operating systems. You can do it now in kicks, but no one ever tried to clean up that technical debt that those people generated. So I think that is a bit special about the DACH market. It's the same in Switzerland and also in Austria, that I observe compared, for example, to the US market. But as I said, I think it's more European versus American thing. I think that's even true for other parts of Europe as well. And when it then comes to the question, how is the skill gap, then I think, of course, we have it. It's not worth to discuss it away. And I think the biggest problems we have is that mostly, as we said in the beginning, people have this feeling the mainframe will go away. And if you hire someone with the 20 years of COBOL experience, 20 years of Kicks experience, 15 years of assembler programming, age 20, income 20,000 euros, then you either get the first 3, but then the 20 years is the maximum of time they have left to work on this planet, and the 2,000 euros maybe the hourly income for them. Or you get the last 2 ones, and then you have someone that don't know anything about the technology yet, but you can educate them. And I think the last bit is the more important bit, that we actually start to educate more and more people, because they are willing to learn. And of course, you need to give them a good welcome. So you don't say like, oh, you need to be an expert and it will be horrible. And actually, we plan to get rid of the mainframe anyways. So don't you want to work for us and do a bit of like support for a dying species? Then no one will come. But if you, of course, say we have these very critical core systems and we need you to help us to also modernize some bits, but also to carry it in the next 20, 30 years of its existence, then I think it is possible to win young people for it. But of course, it is a challenge. And I would say, is it just the mainframe challenge? Not sure. It's the same for big J2EE applications. No one wants to maintain them anymore. And I think we have this big problem that we have this large amount of IT stuff that we work with, and that we are not really good in making it work over decades anymore. Because today we have this feeling of, oh, microservices, you just let them live for 3 years and then you replace them because they're so tiny. They're little microservices. It's not a problem. But then you have like thousands of microservices, and to replace thousands of microservices, then everyone is tiny, but in sum, it's a lot of work. And I think we need to get to this feeling that even software architecture needs to be sustainable. We don't want to redo everything every year, because we will not have the power to actually do so. We miss the skills, but we will also miss the people. Even if we have the skills available, we will not be as many people as we were like 20 years ago.
Do you think I've seen a number, I mean, not too many examples of universities who are organizing some special curricula for mainframe technology? I mean, we even have one in Croatia, and a few very good engineers came out of University of Osijek, but still there are quite limited number of those curriculums. And in the same time, we had quite a good experience. We did a few special bootcamp projects with IBM in Egypt and South Africa. And that proved to be a rather efficient way to, I mean, over the 3, 4, 5 months, you can certainly give the knowledge to young graduates, which and then you can also select those people who are motivated to go for the mainframe, because at the university age, people still don't know what they really want. So what do you think? Which is the way to go?
I just want to do apps, is it? I think as so often in world, we don't need to decide. We can do both. So I actually do teaching a lot at universities, and we have plenty of universities that that we give lectures at. And I think one thing that's so different is people at universities, they usually, when they become computer scientists, they want to get the maximum out of the computers. That's what they aim for. They are computer scientists. Are they really willing to work on a business functionality for the rest of their lives? Probably not. They get bored. So I think it's a mixture. We need, of course, we need people that are thinking it through, engineers that understand what it is and maybe think how to combine it with new modern fancy technology. But what we also should do at the same time, and I have a customer in Switzerland that does that very successfully, you need to have apprenticeships, and you just have new young people that become programmers. They are not going to university, but they understand maybe the business. Maybe they want to become a banks person, but they don't want to have the suit. So you say, oh yeah, you can have your bank experience and help us to program your computers that we need for the people with the suit. So maybe do that. And I think the combination of both is actually very, very, very interesting to me, because then we get as well people that want to drive the technology, but also at the same time people that make the business still work and run. And I think there's no either or. We just need to have the right way to talk to people. And then it even doesn't matter what they did study. So even if they are musicians, but they are interested in coding, why not? Music is actually not that much different than coding. If it sounds nice, it's maybe the same thing as if they produce a good program. So I have colleagues in the development labs of IBM. They did this craziest things, but somehow they ended up in computing and they love it. So
yeah. Who understands Bach music probably would be a very good in programming, I would say.
Yes, agreed. Totally agreed.
Tell me, what's your the most exciting part of mainframe technology right now? I mean, what makes you
get out of bed every morning? Yeah, I mean, I love the whole stack, and that is, I mean, I find something that I really love in everything. So when I look at the chip design, what we did with the chip, most people would say the AI acceleration unit, that's cool. I actually love the cache redesign of the machine, so that we have a lot of cache on every processing core, but also can share this cache between different cores, even across the whole drawer, the whole machine. That's pretty cool. Something that I really, really fancy, because I think producing a 7-nanometer chip, that is like state-of-the-art technology. When people always say, oh, mainframe is so old, I tell them it's like with cars. Cars have been around for 100 years, but you would not go to a modern Mercedes and say, crap, 100-year-old technology. So what we do is really, really fancy, and it will shape the industry for years. But also on a software level, we did cool stuff. We integrated a lot of the open source things. I have a colleague, Mike Fulton, he ports back all the fancy USS tools. You can do now Make on Z. You can do all the fancy tools that you are used to on the x86 world. You can also use on Z, and actually integrate it with ZOS traditional data sets. We do a lot of cool things. And especially in the integration of Java and COBOL and Batch, we did something pretty cool with the 3164-bit integration. So there are cool things that we do. And what really excites me is that people make use of it now. I think that is what really gets me out of bed every morning, that I have meetings with customers where they really want to push it. And it's not like 10 years ago when I was running around like with old beer, here, drink it, finally. And nowadays it's really that people get up and call me and say like, how can I do this? How can I do this? And we need to push the technology again from the customer side, not just from the IBM side, and say, oh, please try Java on Z. Now they try it and they really want more and more and more. And that's really, really cool. And it's a good community. It makes fun. It's a lot of fun.
Okie dokie. Thanks, Toby, for a nice chat. I
You're very welcome.
A lot of good stuff from you. I hope that that our listeners of Mighty Mainframe interview will enjoy it. So yeah, thank you, and thanks for your time.
Always. Thank you so much, and see you soon. Cheers.